Yesterday's last topic is clear. So we were comparing three things together. Okay. So number first, we were discussing about this ammonia. First is your alkyl amines. Second is your aryl amines. Is this clear? Okay. So for today's topic, main heading will be starting from the again basicity of amines. But here there are three theories. Means the theory we were discussing initially. There is a contradiction in between the theories and the practical information. So theory says 1 degree, 2 degree, 3 degree or 3 degree, 2 degree, 1 degree turn. On the other hand, practical information says that all the three theories separately works, means individually the theories are working. But if you want to do overall formation of any compound, so there will not be a process of 1 degree through 2 degree or 3 degree or 3 to 1 degree. Means they have created their own process which was based on the experiment. First we will discuss what theory says and later on we will discuss what practical information says. Clear? So the basicity of amines is covered. So heading is basicity of amines. So there are three theories actually. Okay, according to those theories, we can predict the basicity of any amine compound. Clear? So number first compound here we have, number first theory we have, this is called inductive effect. Okay. So simple inductive effect. The same effect is also follow for the gas phase. What this inductive effect says here, if okay, I'm having 3 degrees or all the degrees of the amine compound. So carbon is connected with one CH3 here. Second, I am having nitrogen which is connected with 2 CH3 group here. And in third case, I am having here nitrogen which is connected with 3 CH3 like this here. Clear? First compound is our 1 degree, second compound is 2 degree, third compound is your 3 degree. Clear? Now, according to the Lewis base concept, if there is any atom which is having a basic characteristics, or we have to find out the basic characteristics is there or not. So we have discussed if the atom has a tendency to lose lone pair or lose electron, okay, electron pair to the positive charge body which is your electrophile. Is it clear? Nucleophile electrophile part is clear now. So if you have any positive, for example, X positive body is there, and if the nitrogen, these lone pairs can easily donate it to this positive charge, so we will say the nitrogen compound is our basic in character. Clear? Now, according to the inductive effect, since nitrogen is having more electronegativity than CH3, so electron density will be toward your nitrogen from this carbon end. In result, electron density will be higher here. So electron density will increase. Similarly, here we have 2 CH3. Since 2 CH3s are there, so flow of electron from both the CH3 will be high. Similarly, here the electron density on this nitrogen will be greater than this one. Am I clear? Because of again inductive effect. Similarly, again here CH3, 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 3 CH3s are there. So all CH3s will be giving the electron to the nitrogen. In result, again the electron density for this one will become the highest. Is it clear? Since you can see the number of CH3s are increasing, so the flow of electron toward nitrogen is increasing also there. Similarly, if the flow of electron will be increasing toward the nitrogen, so there will be high possibilities from the nitrogen to donate electron easily to the positive charge body. Is it clear? If you will have a more electron density, so you can easily donate the electron to the electrophile body. So according to this fundamental theory, which one is more basic? 3 degree is more basic. So according to this effect, we will say that 3 degree, 2 degree and 1 degree trend will be followed here. Am I clear this one? First theory is clear. Okay. After this theory, there is a second theory called solvation effect. Now understand what is the solvation effect. Second theory is called solvation effect, or you can say simple this hydration effect. What is the meaning of this one? Solvation effect says, listen properly. Solvation effect says if water means if the compound is having more tendency to dissolve in water, so the compound will have a more basic character. Is it clear? If your compound has more tendency to dissolve in water, so your compound will be more basic in character. Why? Because water has dual character. It has acidic character and as well as basic character. And it also shows the self-ionization. These points are clear? Okay. So according to solvation effect, again if I am taking these three part, again I am taking these three part here. It cannot be copied, it seems, huh? So here, if we focus on this part, so there are two hydrogen molecules, two hydrogen atoms on the surface of nitrogen. There is only one hydrogen atom and there is no hydrogen atom on the surface of nitrogen. Clear? Easily, if we are having water molecule here, so since oxygen is having lone pair, this nitrogen is attached to the this hydrogen is attached to the nitrogen, so they will try to create a new hydrogen bonding here. Am I clear? Similarly, if I am having one more H2O molecule here, so this H2O molecule will again create new hydrogen bonding with this hydrogen. So indirectly, can I say for this atom there are two hydrogens, so the possibility to dissolve in water is high. Am I clear? Because it has two hydrogen atom. So two hydrogen atom can create two bonding of hydrogen there. Intermolecular hydrogen bonding will be there. Similarly here only one hydrogen is there, so the formation of the means the dissolution possibility will be lesser than this one. Why? It is having two hydrogen, it is having one hydrogen. Because of having one hydrogen, so possibility will be less in comparison to this one. But here, if I keep this part in the presence of water, so it does not have any free hydrogen or directly attached hydrogen to the nitrogen. So there will not be any interaction for the hydrogen bonding. Am I clear? Sir, here no hydrogen, so it will not dissolve. Simple. It has hydrogen, so it will dissolve. It has also hydrogen, it will also dissolve. Why? In these two hydrogen bondings are there, but in this one hydrogen bonding is not there. Are you getting this one? Please do not consider CH3. H from carbons are not involving in the bonding of hydrogen. Why? Carbon is not the part of hydrogen bonding. Hydrogen bonding refers to only for nitrogen, oxygen and fluorine, which is directly connected to hydrogen. If they connect directly to the hydrogen, then only hydrogen bonding will be considered. Otherwise, hydrogen bonding will not be considered. Is it clear? Can you predict the trend based on this fundamental theory of hydration? So which one will be more basic? So primary will be more basic. So here if I want to create a trend, so I will say that in aqueous solution, means in aqueous solution amines will follow this pattern of the process, which means 1 degree will dissolve highest, then second degree, and then third degree. Is this clear? Anyone, any doubt here? Okay. Now there is one more theory, theory number 3, which is called steric effect. Now steric effect says different concept here. So steric effect means steric hindrance effect. What this effect says? If any amine is having possibility to react faster, again listen properly. If any nitrogen is having more possibility or high possibility to react with the other species, so the amine part will be more basic in character. Clear? Okay. Similarly, if we are having 1 degree amine here again, that is NH with CH3. Similarly, the second degree N single bond CH3, CH3, single bond H. And the 3 degree is nitrogen, which is directly connected with 3 CH3. Here I am considering. Clear? All nitrogens are having lone pair as well. Now, the steric effect actually has a different trend. What does that trend? Since we are having 3 CH3 here, so because of their electron cloud, steric hindrance will be highest. Is this clear? Because of the electron cloud, this body will be having the highest steric hindrance. Similarly, it is having only 2 CH3 means 2 side electron cloud. So because of that steric hindrance in comparison to this one, it will be having least or the lower one. Similarly, you have the last one which is having only 1 CH3. So electron cloud will be more or less here in comparison to these two. Now steric effect says if electron cloud is high, so the possibility to react with the other species will be less. Means if the cloud is high, so you cannot move into the reaction. Why? Because the electron cloud will be high and another body will also be having the electron. So electron will generate repulsion and there will not be any process of the reaction. Am I clear? So based on this trend, new trend had come that based on the steric effect, number 1 degree will be the highly reactive, then 2 degree, then 3 degree. Am I clear this one? So there are 3 theories. These 2 theories, solvation effect and this steric effect and solvation effect, they both are discussing and they are focusing on 1 degree, 1 degree, 2 degree, 2 degree, 3 degree, 3 degree process. But this alone theory of inductive effect is not focusing on this same pattern. They are following different pattern, or you can say the reverse pattern. So there is a contradiction in the theories. Is it clear? Okay, first of all, you must understood these things properly. If you have done this one, then we can move on to the next part. Is this clear? Okay, fine. Okay, stop writing. I'll give you the time to note down. Don't worry. Next is, if we have understood this concept, after understanding this concept, now scientists are having a problem that which theory must be given preference. Means which theory we should follow. Now the point, very important point. If the question had come in JEE, NEET or any board examination, if the question had come based on a particularly effect, for example, steric effect, inductive effect, or your solvation effect, if the question had asked directly on those points, so you will follow the individual pattern. Clear? If they had not asked any particular mention point, for example, steric effect or inductive effect or any other effect, so you will be following the effect which we are going to do now. Is this clear? So when the 3 theories of the basicity of amines had come into the contact, so scientists had actually a dilemma which theory should be given the more priority. So instead of giving priority to the individual theories, they have done practical data also, means practical experiments were also done there. So based on practical data, it was observed that neither 1 degree nor 3 degree, they like both are not following the highest level of the basicity. So they have concluded in all the cases, whatever the case is there, in all the cases only 2 degree amines were found the highly basic in nature. Am I clear this one? So number first effect we had discussed, that was our solvation effect. For example, hydration effect. So in this hydration effect we had understood that 1 degree was the highly, then 2 degree, then 3 degree. Second effect we had understood, that is our inductive effect. So based on inductive effect, 3 degree, then 2 degree, then 1 degree. Clear? And the third theory we had understood, that is called our steric effect. So in this steric effect we had understood 1 degree again, 2 degree again, and then 3 degree. So we had a problem to predict the main result. So scientists have actually done the experiments to find out the best result. And the best result was found, that is, it is 2 degree, sometime it was found 2 degree, 1 degree, then 3 degree, and it was also found like 2 degree, 3 degree and 1 degree. But the point is, in both the degrees of the formation, 2 degree was the common one. Clear? There is a problem 1 degree and 3 degree. So question is, how will I get to know, sir, this is 1 degree or the 1 degree is given here, or in which trend I will follow the 1 degree, or in which trend I will follow the 3 degree. So simple, 1 degree means if the small chain or small carbon chain is there. Okay. So you will follow this pattern of 1 degree. If small means, for example, if I am having 2 degrees, so I am writing directly CS3 whole twice and this is my 2 degree. 1 degree of this one it is, that is CS3 NH2. And then I will write down 3 degree, which is called CS3 whole thrice and N. Means if carbon chain is small, so you will follow the small number at the center. Like this you can understand, or you can make your trick. Clear? On the other hand, if the carbon chain is bigger, now the carbon chain is increasing. So instead of giving the priority to the 1 degree part, to the small carbon chain part, you will give the priority to the 3 degree big chain part. Clear? So number 3 is bigger. You can also remember like this. Since the number 3 is bigger in comparison to 1, so 1 means short chain or 1 degree, or like this means you can create your own trick as well. Since it is a small number, so small carbon chain is going on. Since it is a big number, so the big carbon chain is going on there. So 2 degree in both the cases. For example, if I am taking here CS3, CS2 whole twice nitrogen. So this is the part of 2 degree here. Okay, H will come here. Clear? 2 degree. Then after that 3 degree will come here. So nitrogen, which is directly connected with CS2, CS3 whole thrice. And then the last one will be your 1 degree, that is CH2CS3, which is NH2. Clear? Okay. Mathematically, you can also find out the answers. How do we find the answers mathematically? By the help of ionic equilibrium. Okay. Now, what is the concept of ionic equilibrium? Just now we have understood that amines are basic in character. If you try to dissolve in the water, so they will dissolve in water, despite they should have hydrogen. If they do not have hydrogen, so they will not dissolve in that. Clear now? Similarly, mathematically also you can find out the answer, which says if any amine compound, for example CH3NH2, if you dissolve in water, because of the self-ionization property of the water, this part will convert into CH3 and H3 positive part, and plus OH negative. So here I am considering these are the concentration. Is it clear? Huh? So this bracket means I am not taking a normal values, it has a specific concentration also. Since your products are in ionic form, so reaction will be in equilibrium or the reversible part. Is it clear? Anyone any doubt in this line? Clear na? Okay. Since the reaction is reversible, so you can apply the equilibrium constant also. If it is related to base, so you will write down the value of the base. So instead of writing Kc, you will write down Kb. So Kb will equal to product of CH3, NH3, positive charge, and this one OH negative, divide by, here you can write down that is concentration of CH3 and NH2. So water concentration will be taken as 1. Clear? Because of the active mass, if you take the pure liquid in very high quantity, so active mass will be considered 1. Is it clear? Based on this value, if the value of Kb is high, so simple, your basicity will be high. Is it clear? Again, sir, Kb value can have multiple values. For example, the big value or the very small value as well. So, to determine the same value in simple manner, you can also write down. Everybody know the value of pH is written equal to minus log concentration of H plus ion. This you know na? Similarly, by following the same pattern, instead of writing directly Kb value, you can write down the pKb value, which is equal to minus log, instead of writing concentration of H plus, you will write down Kb. Is this clear? Anyone any doubt? But for this one, remember, pKb value is inversely proportional to the Kb value, which means if the pKb value is high, so your basicity will be low. Am I clear? So directly I am writing down this one also, that is 1 upon basicity of amines. So directly now you can predict based on mathematical relation also, which is also given in the book. Clear? So how many methods you have understood here? First you have understood solvation effect. Second you have understood the steric effect. Third you have understood the inductive effect. Based on these theories, you had a problem to predict the answer. So instead of struggling with these three things, directly now we are having our own answer, which is 2 degree, 1 degree, 3 degree, or 2 degree, 3 degree, 1 degree. Clear? But in the answer, common is your 2 degree. This point is clear? After understanding these things, we have another method also to find out the basicity, which is called mathematical formula. Since basic means amines are basic in character, so if you dissolve in water, they will be having their ions. In respective ions, use the formation of the Kb, and directly if the Kb value is high, so answer will be high or basicity will be high. This concept is actually used when the values are given to you. But if the values are not given to you, so how will you use the value? Clear? How will you predict the answer? That's why mathematical relation we have done in the last part. Clear? So is this point clear? Now you copy it properly. And please don't make mistakes, because this part I have already told, this is a contradictory theory. So concepts should not be shaken up.